So last year we talked about, again, the possibility of being able to 3D print a device like a cell phone. Well, we're starting to get in that direction here. Now, we just talked about 3D printing technologies where you could print a structure, a structural shell, for example, for a cell phone, and then be able to print the interconnects using pick and place to be able to drop in chips, device chips. You could start seeing this become more of a reality.
So for me, I've been involved with additive manufacturing for about 25 years. We did our first part prints were for the Sonic tray we designed here at Magnet. I printed those parts and presented them at the design review, and the engineers that we did the work for just about fell off the chair. And so right then I realized how impactful additive manufacturing is, can be, and is going to be. One of the things we do here at Magnet is to engage companies in the additive manufacturing sector and then bring that technology to people that might not normally use it. So you wouldn't think of a stamper as being somebody that could use additive manufacturing to make parts, but we can show you how to do that. Same way with injection molders. Same way with people that do textiles. So it's really, that's where I see a huge transformative element to this technology. The classic quote I recite from Terry Wohlers is the fact that if you're not running in this space, you're falling behind. So what that means is companies should have a bullet point on their monthly strategic meeting that what are we doing in additive? And if that isn't there, they're falling behind, because additive is on an asymptotic growth curve and there's no stopping this technology. Some of the supply chain transitions that we are in the preamble of right now are going to be transformative. Because this technology is evolving, we're going to be able to print faster, better, stronger parts. We're not going to have an inventory sitting on shelves. We can have the raw materials and the equipment and then print as needed. So if somebody has a special order part or a special need, we can do that on site, on demand. So we're really in a transformative phase. What we're doing is we're transitioning from the mass production to mass customization with this equipment. One of the interesting aspects of additive manufacturing is that we can take a scan from a part, regardless of where that part came from, get it into our CAD system, manipulate, modify it, and actually make that part. So there is some issues potentially with people actually getting into copyright infringement potential. Very easy to do that. So this is a good example of reverse engineering a part. So this is actually a Porsche 356 door handle that we did for Stoddard Parts. So they do a lot of the vintage parts for Porsche. And we actually do their scanning and reverse engineering and develop what's called a technical data package. So they can take this part and have it made anywhere on the planet, really. So the last version of this was probably made in 1978, and Porsche made 500 of them and thought we'll never sell 500, we'll sell 100 or 200. Well, all those people that embraced that car when they were younger now have disposable incomes, and a $250 door handle is not an obstacle. So we do a lot of stuff like this where we're reverse engineering vintage parts.
We know that some of the smartphone companies have purchased 3D scanning companies. So we could start seeing this technology being democratized. At the same time, there is a need for precision scanning, and there are companies out there that are trying to meet that challenge. And the real issue with precision scanning is reverse engineering. Reverse engineering of spare parts, reverse engineering of hard-to-find parts. That's where precision 3D scanning can be necessary in order to have a part that may fit into a larger system such as an automobile or an aircraft.
Talk about spare parts. Lowe's Innovation Lab recently partnered with a company called Authentize to put 3D printing in stores. It took 6 months to pass legal review, I'm told, and I'm sure even then there was a highly qualified yes, and Lowe's was apprised of the risk. Spare parts like automobile parts can be scanned and printed. We know this. Some companies are understandably concerned about their customers having the ability to scan replacement parts for the big machines they purchased instead of purchasing the parts as they always have from the OEM. It's a significant loss of revenue and creates product liability issues, warranty issues, IP issues. Now Lowe's is going to roll out a scanning service in certain stores. Customers will be able to bring files into the stores and have the parts printed, or bring in a functional object such as an out-of-stock light switch or a spare part, and you can get that scanned and then printed right in the store. Also, design services will be offered. So from the back of the customer's envelope to a CAD drawing to the final physical thing. Now big box stores, Lowe's won't be the only one, can work with customers to print out of stock items, and there is a huge demand for this.
So Local Motors is a company that actually is printing a car. So you can print a car in 44 hours. They put in a lot of the hardware, so electrical wiring, motors, batteries, drivetrain, things like that are actually conventionally made, but the actual structure of the car is printed. 44 hours, printed car. And their goal is to actually develop that into a manufacturing process where you can actually go and buy a customized car. Part of my background with Porsche was in the motorsports realm. So just imagine what you can do if you can print parts, right? You can modify parts, you can make things better, cheaper, stronger, faster. So there's things out there that are absolutely at the pinnacle of performance. So what we have now, I think of it as a convergence. We have software that can design the most complicated, perfect part. So what I call an ideal final result. And now we have equipment that can make that. You know, a decade ago, we could not make some of the parts that we could design. So aerospace, Elon Musk is using this technology to take a price point to get 1 pound of material into low Earth orbit to $1,000. That's their goal. So right now, we're in the $15,000, $10,000 range. Elon Musk's goal is to take it to 1,000, and he's doing that with a lot of additive manufacturing equipment. So they print their nozzles, they print a lot of engine parts, they print hardware, fabrication, brackets, things like that, all with AM technology. But this is an aluminum part printed off of Ultem, which is an FDM, high temp material, high strength material, and then hydroformed. So conventional tool for this to be a stamped part is 8 weeks away and probably $50,000. The tool to make this part is 4 hours away and $350. So we're not taking time out by transitioning weeks to days. We're taking time out by transitioning weeks to hours. And that's how transformative additive manufacturing can be. This is I think 52 days to 2 days, and $58,000 to $2,800. So it's in the 98% reduction in time and cost. There's a lot of propriety in the actual composition of that materials, right? So that's one of the revenue streams for Stratasys and Objet is the raw materials. They want to give you the equipment, and then the revenue stream comes in on the raw materials. So it's sort of like HP and the print cartridges. You know, you buy a $45 printer, and then the printer cartridges are $30 or something like that, and Gillette and the razor. So they give you the razor, and then you have to buy blades for the next 10 years or something like that. So that's their business model.
So materials will be very important as we move from prototyping into commercial embodiments. And not only will the machines that we use to make the products be patentable and the software and the processes used with the machines, but also the materials. But I think as a chemist, one of the most important things that we can consider are the commercial aspects of trade secrets and how we protect those materials from competitive knowledge with trade secrets as opposed to patent protection.
When we think about the material properties, 5 years ago, the machines we have here at Magnet, I had a choice of 60 different materials that I could put in that machine to create parts from. Now it's over 660 different materials I can put into the equipment downstairs. So what that gives me is a very unique potential raw material selection for actual production. So rather than having prototype parts, we transition out of the prototype arena and into the production arena. So we can actually print real parts that go into production equipment right now.
Materials lend themselves to trade secret protection much more than the processes and the machines used to produce 3D printed objects, because they can't be reverse engineered for the most part, and so the chemical makeup of those materials can be protected without going to the patent office.
A technology company making an impact is Voxel 8, hatched in a Harvard lab by Dr. Jennifer Lewis. The mission is to print functional objects, to advance materials to the extent that totally functional objects can be printed out in one build. Voxelate focuses on conductive inks to embed electronics. Multi-material print heads were developed for this purpose. Mixing, switching nozzles, print metals to ceramics to polymers, incorporating functional and flexible electronics. One nozzle extruding plastic, one nozzle extruding conductive ink. Print the wires for wearable sensors, wear a bandage on your knee, and receive data about the body. The interesting thing is that Voxelate is focused on the desktop. It recently raised $12 million in financing and is rolling out the developer's kit for the desktop. Another exciting 3D company I became acquainted with at CES this year is Carbon 3D. Raised $100 million last August, led by Google Ventures and Sequoia. Carbon 3D asks the philosophical question, does the part being printed have the necessary qualities to be a final part in an automobile, in an airplane, etc.? And that all comes down to parts printed with the right materials, which is the focus of Carbon 3D. In other words, does the part have the durability to operate under the hood? Carbon 3D says it wants to own the intersection of hardware, software, and molecular science. We know that the need for speed and more robust materials at reasonable prices will drive mass adoption of additive in manufacturing. Carbon 3D has some exciting materials, rigid materials, semi-rigid materials that can be used in hinges and clips, materials perfect for surgical tools, great color gradations, all in one build, all the beautiful colors of injection molding, all the complexity of 3D printing. Silicon Valley has always been really good at software, now it's getting great at molecular science too.
Carbon 3D takes a different approach, and so parts that used to be made in hours can now be made in minutes. And so that's a significant paradigm shift. Now they're doing plastic parts with this technology, but the speeds that they're talking about, now we can start looking at other applications.
So with CLIP, Carbon 3D targets the automotive industry, consumer electronics, athletic apparel, aerospace, among others. And obviously these industries are very interested based on Carbon 3D's high valuation last August from Google Ventures and Sequoia. What seems completely logical and is happening is that many 2D printing manufacturing companies are now launching 3D printing machines. In my opinion, at CES this year, HP was the most impressive. Thermal inkjet technology is what it's good at. A density of nozzles within a defined space. No moving parts because it's thermal technology. Each print head has 10,000 nozzles, and each can fire 48,000 times a second. That is a lot of data. HP also uses multi-jet fusion technology. It's accelerating the speed of builds.
Hewlett-Packard, HP, now coming out with printing technology. Multi-jet fusion is what they call it. Multi-jet fusion, it's again a nexus between materials, in this case primarily the resins that are being used to bond materials, as well as the printing process. Now they haven't come out on the street yet with their machine, but they are focused on business and industrial applications, again looking at production. It's plastics again, so polymeric-based applications, polymeric-based materials, but they're looking to increase the speed as well. And so HP also brings, of course, their entire distribution network, their supply chain that they bring with them, what a lot of current 3D printing manufacturers don't have. So it's possible that we could see a significant sea change with that technology. So speed to market, speed of the process, enabling speed to market, enabling new market opportunities, and materials being a significant driver.
When things are digitized, ones and zeros, we need fantastic technology to transform the digits back to physical form, and HP is one company providing this.
I look at Northeast Ohio. This is the rising of the Phoenix. Within 500 miles of Northeast Ohio, 60% of the manufacturing base. We have the skill sets, we've got the toolbox, we've got the resources here, and we're talking about the sexiest story in manufacturing, which is 3D printing. It completely flipped a traditional manufacturing company into an advanced manufacturing company. Manufacturing, as we know it, has changed dramatically. Advanced manufacturing is the dawn of the new day. You're combining traditional processes with 3D printing, but it's driven by applications, and it's unique to each individual's opportunity or new product that they want to create. What we see the future will hold is we are changing from design for manufacturing to manufacturing by design. This is the intersection of software, materials, design, and process. As we continue to iterate down the road, manufacturing will continue to become more specific, mass customization versus mass production. We have been able to grow sustainably year after year because we bring value to the table each and every day. Whether it's our culture and our people, whether it's our technology and our equipment, it ultimately boils down to you've got to build relationships on the foundation of trust. We have demonstrated over and over again that our clients can trust us. And we help our clients meet their goals and their challenges by trying to seek and find new solutions that they don't have time to find. And we bring those solutions to the table. That's why our customers come back over and over again. You have to build a strategy, a short, a mid, and a long-term strategy around 3D printing and how does it impact your business. Our customers have cost constraints, they've got timelines, they've got budgets, they've got resources. We look to see where the waste is. We're a problem solver. We create solutions for our clients. Having a combination of the technologies together creates the ultimate solution. We are going to build the manufacturing revolution in the Midwest. Additive is going to drive it. Having those toolkits all working together to collaborate will create a much more harmonious and successful economic region.